Hello, everyone. So in this video, we will be talking about unit conversion, but we will talk about the units that are either squared or cubed, and we want to learn how to work with those problems, okay? So let's take an example that you're given a number 56.58, and this number, let's say the unit given is meters cube, and I want you to change it into centimeters cube. Then how would we approach this problem? Okay, so it is going to be similar to the problems we saw earlier in the last video where we learned the prefixes, but we didn't see the cubed one, so that's what is different here. So let's see how to approach these. So one thing we want to understand, first of all, is what is this unit referring to? Like, when do we use meters cube? This is referring to volume of some space, right? So let's say you're given a container and you're trying to measure that inside that container. So for example, you have oxygen cylinder and how much oxygen is inside that container. You're going to be measuring that volume in either meters cube or centimeter cube, or you will actually be measuring it in liters. Okay, so for volume, there are two types of units that are used. It's either liters that you use, or it is these cubed units that you use. Okay, of course, those are then modified with different prefixes, like liter can become milliliters, meter cube can become centimeters cube. So those modifications are possible. Usually liters is used for liquid, whereas when it comes to solid things, and let's say you're trying to find out the volume, the size of a bedroom, for example, then you're not going to be finding it in liters. You're going to be finding it in like feet cube or inches cube or meters cube or centimeter cube, something like that, right? So that's where this works. So right now the idea is to change meters cube to centimeter cube. How did we get the meter cube? So for example, guys, if you are dealing, with a room, then you know that you're working with 3 dimensions, and in a 3 dimension, you not only have you not only have let's say if you're calling this the length and you're calling this the width, then you also have what you call the height. So you have 3 sides, 3 dimensions that you need to multiply. So if this reading height is in meters, for example, if this is in meters, this is in meters, and this one width is also in meters, you will multiply all those 3 sides to get the volume of this cube, right? So that's where this is coming from, right? So what we need to understand here is that when you're changing meters cube to centimeter cube, in the back of your mind, understand that there are 3 meters that are sitting inside meter cube, right? A meter for height, a meter for length, a meter for width, okay? And each of that meter is going to be changed into centimeter, okay? So that's why our unit conversion factor will also be cubed, okay? So what does that mean? So if I have a 1 meter cube, what does that mean? That, for example, I'm working with a cube, and that cube is 1 meter by 1 meter by 1 meter. Okay, the answer for the volume will be 1 meters times 1 meter times 1 meter. The answer I'll get is 1 meters cube, right? If I'm trying to change that into centimeters cube, I need to keep one thing in mind. And that thing is, let's break this down. 1 meter cube means this. It means 1 meter times 1 meter times 1 meter, right? We are trying to change it into centimeters cube. So let's break that down as well. Centimeter cube means this: centimeters times centimeter times centimeter, right? So each of that meter needs to be changed into centimeter. So if you notice here, each meter has its own centimeter. Each meter has its own centimeter. So this 1 meter, the first one, when I'm changing it into centimeter, what number should go here? So this, we need to remember from our previous studies. We learned that the conversion factor for meter to centimeter, how will you synthesize this, guys? Remember which one is the bigger unit out of meter and centimeter? Meter is the bigger unit. So meter should get 1 in the front. So let me show you this the way we were doing our problems earlier. So for example, if meters were sitting in the bottom and centimeter was sitting here, how would we make the conversion factor? So meters is no prefix in the front, so it's 10 to the power 0. And centimeter is 10 to the power -2, right? So which one is the bigger unit out of these two? Meter is the bigger unit. So you will put 1 in front of the bigger unit, which is meters. The centimeter will get 10 to the power some number here. What will that number be? That number will be the number of jumps. So I just applied the golden rule that we learned in the previous video for unit conversion, okay? So how many jumps do you have when you go from 10 to the power 0 to 10 to the power -2? That's 2 jumps. So the number I'm going to put here is going to be +2, right? Remember the golden rule, always positive exponent. So 1 meter, so this is such a common conversion factor that I would just remember it. And not waste my time in making that conversion factor. So 1 meter is 10 to the power 2 centimeters. Okay, so let's go back to this problem now. So guys, this 1 meter, when it's changed into the centimeter, you need a 10 to the power 2 here. Okay, the next 1 meter also needs its own 10 to the power 2 centimeter. The third one, same 10 to the power 2 centimeter. So basically what this is trying to say is 1 meter, when it's cubed, then when you're cubing the centimeter also as cube, you need to multiply these numbers here, right? So what is 10 to the power 2 times 10 to the power 2 times 10 to the power 2? It's 10 to the power 2 plus 2 plus 2. What is that equal to? It's equal to 10 to the power 6. So guys, I hope this is conceptually making sense to you. This is actually showing, this step here is actually showing you how you can change a cubed unit to a unit which is also cubed. Okay, so again, when you're trying to do a conversion factor where there is, prefixes involved and they're cubed, then you have to follow this methodology. Okay, so this showed you how this is actually working. But if you quickly want to do a problem like this is how you're supposed to do it. Let me show you a quick way to do it. Okay, so if the units are cubed, their conversion factor must also be cubed. That made sense, guys, here? Let me rewrite that. If I have 1 meter, I know that 1 meter is 10 to the power 2 centimeter, right? We know that. We know that from here. 1 meter is 10 to the power 2 centimeters. So 1 meter is 10 to the power 2 centimeter. If the meter is cubed and this centimeter is also cubed, then its conversion factor should also be cubed. That's all what it means. And you see, 1 times 1 times 1. So 1 cube is just 1. Meter cube is meter cube. 10 to the power 2 cubed is what, guys? How do you solve this type of parentheses exponent powers? What you do is, to get rid of the parentheses, you just multiply those two powers. So 2 times 3 is equal to 6. So this becomes 10 to the power 6. Okay, so don't add them. Don't add 2 plus 3 and make it 5. When you see two exponents like this in parentheses, that means you need to multiply them. 2 times 3 is 6 and centimeter cube. So guys, you can get the answer 1 meter cube is 10 to the power 6 centimeter cube by just keeping this in mind, that you can cube the individual conversion factor, or you can conceptually think like this. Both will get you the same answer. Okay, so now let's go back to the problem that we were working with. So we had 56.8 meters cube, 56.8 meter cube, and we wanted to change it into centimeters cube. So for right now we understand that we can that this is the conversion factor we're going to be using if we have meter cube and centimeter cube. So we're just simply going to plug that in here. So copy paste what you already have. What unit should go here, guys? We have 2 units, meter cube and centimeter cube. Can you guys quickly tell me what should we put here? We should be putting meters cube, right? Why are we putting meter cube? Because we want to get rid of it. We want to get rid of the meters cube, okay? All right. So that's a meter cube. And what goes here is a remaining unit, which is centimeters cube. What numbers goes here? We already figured that out, that 1 meter cube is 10 to the power 6 centimeter cube. So now what is left is you just, simplify this problem and you get to the answer. So this becomes 56.8 times 10 to the power 6 centimeter cube. Again, to get to the scientific notation, we make this 5.68 times 10 to the power. How many centimeter cubes? So what will be that exponent, guys? You figured that out? Pause the video again and tell me, how do we solve this? Okay. So what do we do here? 56.8, you're making this number 5.68. Did you make it big or small? You made it small. If you're making this small, you got to make this number bigger. Okay, you made it small by 1 decimal place. You got to increase this number by 1. Okay, so 10 to the power 6 will become 10 to the power 7. And this will be the final answer for this. Okay, all right. Okay, so let's do another problem. So another, let me actually quit the program. Sometimes it's gonna act up like that. Okay, so the next thing that we will be discussing is the conversion of the volume from one volume unit to the other volume unit. Remember I mentioned that for volume, you have 2 units basically. One is liters, the other one is meters cube. So we want to make sure that we understand how to go from one unit to the other unit, because this is useful. So for example, you're given a volume for a solid object, and you're trying to think, okay, that volume of a solid object will correspond to how much liquid inside that container. So you should be able to make the conversions between these two. Okay, so the conversion that we need to remember is that 1 liter is 1,000 centimeter cube. Okay, 1,000 means 10 to the power 3. So this can also be written as this, because this is one conversion factor that you want to keep note of. This will come in handy whenever whenever we have to make a conversion where you're changing a unit from one base unit to another base unit. So what we have been learning so far, like the previous problem we saw, it was meter cube to centimeter cube, meter to centimeter. You see both had meters in them. This is different. You're changing liters to centimeter cube, right? So you have actually changed a liter to a meter. So you have changed that here. Okay. This is something important you want to remember. Okay. All right. So let's do. Let's also remember one more thing, is that 1 ml is actually equal to 1 centimeter cube. So this is also, again, it's the same thing like what you see on the top. 1 liter is 1,000 centimeter cube. If you get rid of the 1,000 here and you make this also 1,000 times smaller, you see liter becomes milliliter. So the idea is that if you're given ml, it is equivalent to centimeter cube. If you're given centimeter cube, it is the same thing as ml. Without any conversion, you can actually switch your answer. So if I quickly just tell you that I have 9.78 mLs, you can simply call it 9.78 centimeter cube without any math, no change required. The value stays the same. 9.78 stays 9.78. ml and centimeter cube are equivalent. Okay, all right. So now let's do a problem here. So let's do a problem here where we need to change. Let's do one advanced problem here. Okay, we want to change something which is let's pick the same number, 9.785 times 10 to the power 2 milliliters, and you want to change that to inches cube. So this is a little more advanced problem, and you want to make sure you understand this, okay? All right. So what do we do for a problem like this? Again, copy paste the number that are given. Before that, let's make a plan in our head how this problem will work out. So we know that if you're going from mLs to inches cube, what connection can you think of when you're going from this ml to inches cube unit, okay? So know that whenever you have this liter to this cubed thing, whatever cube, inches cube, centimeter cube, meter cube, remember you're going to be using one of these two equations for sure, okay? So you can change this mLs to centimeter cube, and then think if you can change centimeter cube to inches cube. Okay, so we know already that 1 inch is 2.54 centimeters. Okay, we're going to be using this information as well to solve this problem. Okay, all right. So let's start this problem here. Okay, so we'll be copy pasting what we have. So 9.785 times 10 to the power 2 mLs, and then guys, this is one of those problem where we will do the conversion, but we will need multiple steps. Okay, why do we need multiple steps? Because this problem cannot be done in by using just one conversion factor. If you figured out that you need 2 steps, like you see this arrow, the first arrow and the second arrow, if you think you need 2 steps, you will be making conversion factor like this. So let's see how to solve this. Okay. All right, so ml is what we are starting with, and first of all, centimeter cube is where we're going to go, and then from centimeter cube we'll go to inches cube. Okay, all right. So now ml sitting here, what unit should go here? Should it be ml or centimeter cube? Of course, it needs to be ml so that it can cancel. So centimeter cube will go on the top. Okay, for right now, we'll just keep going with the units so that we can set up our units first, and then we can put in the numbers here, the conversion factor, okay? Okay, what is next? So let's keep going with just the unit. So centimeter cube sitting here, I'm right now here, centimeter cube. I want to go to inches cube. So centimeter cube sitting here, I want to put centimeter cube sitting here so that they can cancel. And I can then go to inches cube. Okay, so now let's put in the conversion factors. Okay, so what do we know, guys? What do we know about the ml and centimeter cube? We know that 1 ml is 1 centimeter cube, so I can just put 1 and 1 here. It's very, very simple. So technically, even if you had missed this step, then it will not make any difference to the answer because it's just a 1 and 1 here. So you're multiplying it by 1 and dividing it by 1. So that does not make any difference to the answer, right? So ml and centimeter cube can just simply be replaced. Okay. All right. Now, the next is how to go from centimeter cube to inches cube. That is what is important here. So when both the units are cubed, you got to remember from the example we did earlier for the meter cube and centimeter cube, is that whenever the units are cubed, the conversion factor should also be cubed. It's as simple as that. So if you know that 1 inch is 2.54 centimeters, so if this is given to you already, then if I cube the inches, then this 1 needs to be cubed as well. If the centimeter cube is cubed, then this 2.54 needs to be cubed as well. Okay, so basically 1 inches cube is equal to, what you will need to do here is to pause the video and cube 2.54. So 2.54 times 2.54 times 2.54. So what I get is 16.387064. This is what we get. Okay, and then you have the centimeter cube sitting here. Okay, all right, so this is the conversion factor we can use that we can plug in here. Okay, so 1 inches cubed equals 16.387,064. Okay, all right. So now what you need to simply do is to simplify the problem and get to the answer. So what do we do here? So 9.785 times 10 to the power 2 times 1 times 1. So I'm just gonna ignore that. You have inches cubed sitting on the top. And let's first of all quickly check all our units. ml cancels, centimeter cube cancels, inches cubed left, and that's what we wanted. We wanted inches cubed. Okay, so let's go back here. The bottom number is 16.387,064, right? So what are you basically doing? Is just you're gonna divide those two numbers. So 9.785. So if you want, you can multiply it with 10 to the power 2, or you can just take 9.785 and divide it by 16.387,064. So the number that I get when I divide those two numbers, I get 0.597117336. Okay, and I still have that 10 to the power 2 left over, and then the inches cubed. Okay, so with that, of course, this is pretty close to the final answer, but there are a couple of things that we need to do. We need to keep in mind the significant figures and scientific notation. Okay, so for when it comes to scientific notation, that we know that we just simply move the decimal here to the right so that the decimal falls between the first two non-zero numbers. So now what we need to do, guys, when we actually are moving decimal, we need to do something with the exponent, right? So if you're making the exponent, if you made this number bigger, you have to make the exponent smaller. What does that mean? That if you're moving decimal to make the number bigger, you have to make the decimal smaller. I mean, you have to make the exponent smaller. So 10 to the power 2 will become 10 to the power 1. Okay, so this answer right now is okay with scientific notation, but it's still not okay with the significant figures. So guys, the significant figures will come from the number that you started. This number has 4 significant figures, and all what we did was multiplication division. So we just go by the least number of significant figures. So we have 4 significant figures, so I can only keep the 4. So the 4 that I keep are the first 4, and all of the remaining numbers need to be dropped. So this becomes 5.971. The first number you're dropping is 1, so you don't have to increase the previous number. So this is going to be the final answer. Okay, all right, I hope this makes sense. We'll see you guys in the next video.